Hello, my name is Angela Benavides and I will present my artificial intelligence project. I created a pet sitter that uses artificial intelligence to navigate around the house, search for and recognize a dog. I will show you the milestones that I accomplished and the challenges faced during the process. Let's start with localization. For the initial steps, I work with the IDE Calico that allows me to use a robot simulator and gives me the sensors and camera information. To navigate around, the pet sitter first has to know where it currently is. While the robot has a complete map of the house, it will have to use its sensors to determine its location. I start by discretizing the map into a text file and then loading this information into Calico as walls. I use a hidden Markov model for localization to calculate the possible positions of the robot given the observations of the sensors. To get the sensors data, I use the getObstacle and getDistance functions from the robot. Then, I created a function that, given the sensors data, reports if there is a close obstacle in the north, south, east, or west direction. Finally, based on the obstacles found, I calculated the probability of the robot to be on each cell of the map. Then, while it's moving, I calculated the new position using the probabilities to determine how likely it was to move to the next cell. This gave me the new possible current positions of the robot. The higher the probability, the darker the spot in the localization area. Now, let's continue with exploration. I programmed the robot to explore the entire room by going from one side to the other. Unfortunately, this wasn't enough to explore the place because the robot sometimes decides to go against the walls. To fix this, I stored the actions previously executed by the robot and calculated the visited area. With this information, the robot should be able to decide where to go, considering the walls around and the unexplored area. This will continue until there are no more unexplored cells around. For future work, we could use a search algorithm like BFS to find the shortest path to an unexplored area. Next, I tried in a real robot. I am using a scribbler robot with a fluke board. Together, they can detect obstacles in the front and back area of the robot. I am using the Calico IDE and a Python program to send commands and receive data from the robot. But the real world is not ideal as in the simulator, and the robot kept miscalculating the distances to the real walls or spinning less than desired because of the friction with the carpet it was on. To solve these problems, I tried doing a calibration to adjust the distances for the obstacles function. This improved the exploration process, though it's still not perfect because there are so many factors that can affect the sensor's readings. For future work, we could try using a robot with more accurate sensors. Finally, let's find the dog. I use CafeWeb. It works with a CafeNet model that is a replication of the model described in the AlexNet publication. A neural network that consists of 5 convolutional layers and was trained over 1.3 million images from ImageNet. But in CafeNet, the pooling is done before normalization, with an accuracy of 57.41% and loss of 1.82. Every time the robot takes a picture, my Python program sends it to CafeWeb, reads the classification results, and beeps if there is a dog among the guesses. Then, the robot should explore around its current position, take pictures, and stop when it finds the dog. Finally, I want to show you how the pet sitter works using localization and exploration to go around the place and search for the dog. Most of the time, the dog classification works correctly. But sometimes it doesn't, like here, where it failed to find the dog, or in these ones, where incorrectly found one. And other times, the camera fails and takes pictures like this. In conclusion, in this project I show how to use a hidden Markov model to locate a robot in a house and navigate around it, and a neural network to find the dog.